Welcome to chapter 11, super quick walkthrough. Kitties, timer, ready to pause? Here's the info. The original question A, question B, question C, and question D. Remember, solutions are coming up. All right, so 2 statistics. Students wanted to know if including additional information question would change the distribution of responses. To find out, they randomly selected 30 teenagers and asked them one of the following questions. 15 were randomly assigned to A, 15 were randomly assigned to B. A says, when choosing a college, how important is a good athletic program? Very important, important, somewhat important, not that important, or not important at all. Question B, however, gives this first sentence. It's sad that some people choose a college based on its athletic program. When choosing a college, how important is a good athletic program? Very important, important, somewhat important, not that. So there's no difference from A to B on the second sentence, but that very first sentence is important, right? It's sad that some people choose college. So they wanted to know if including that additional biased bit of information, would it change the distribution of responses? So they summarized the data here, and they already figured out the chi-square test statistic was x squared is equal to 6.12. Cool. So let's dive on in with our answers. State the hypothesis that the students are interested in testing. That's easy enough. Well, they wanted to know if including additional information in a survey question would change the distribution of responses. So the null would be, of course, that the distribution of responses is the same for both questions. And the null would be it's not the same. And it's not that we know it's going to be greater or less. We don't know if it's going to incline the students one way or another, but it's just going to be it's not the same, right? We don't know which one. Moving on. Let's describe a type 1 and type 2 error in the context of the hypothesis stated in part 1. So to recall about type 1, type 2, I pulled up this little image. I really like these little charts to help understand this. So if I'm looking at the null hypothesis and I have, let's change the language here. I have failed to reject. So we'll do that. So if I have, let's start with rejecting the null. So here's my null hypothesis. I don't know why I wrote that. Okay, so let's say I reject the null. We'll start there. I reject the null, which means I agree with the alternative. So if I reject the null and I'm incorrect, that's called a type 1 error. If I reject the null and I'm correct, great. If I fail to reject, so that means I agree with the null. If I fail to reject and I'm correct that the null hypothesis is true, great. But if I fail to reject and we should have rejected, it was a false null hypothesis, this is called type 2. To help you picture this even more, type 1 error would be telling a man you're pregnant, a biological man. Type 2 would be telling a biologically female woman who is currently exhibiting symptoms of pregnancy, you're not pregnant. So you can kind of set that up. It's just a silly little image to kind of give you an idea of type 1, type 2 error. So type 1 would be that we found convincing evidence that the true distribution of responses was different, but that's not actually true. The true distributions were really the same. Type 2 would be that we did not find convincing evidence that they were different, but that's actually not true. The true distributions really weren't the same. So those would be the two type errors with context from the question. Let's look at C. For these data, explain why it would not be appropriate to use a chi-square distribution to calculate the p-value. Some of you might pause and say, hold on, they did calculate the chi-square distribution, so why wouldn't it be appropriate? And that would be going back to that step number 2, plan. When we plan, we don't just name the procedure, we test if conditions meet. So let's test our conditions. Random, we could meet. I think they were randomly assigned to each category. And the 10%, cool. But look what happens when we hit that large counts condition. All of the observed, I have to go all the way back, sorry. All of the observed counts, or many of the observed, I lied about all. Many of the observed counts are over 5 or equal to 5. Cool. But that's not where we look. It's the expected counts that have to be greater than 5. And since they're all less than 5, it doesn't meet large counts normal conditions, so we wouldn't actually apply a chi-squared distribution. So the way that these kids are originally using their statistics, you as a statistician would say, no, it doesn't quite meet conditions. So we wouldn't actually apply a chi-squared distribution to this question. But for D, to estimate that p-value, let's say we said, okay, well, we can't quite pull a chi-square for the original data. Let's pull 100 trials of simulations. So let's pull a sampling distribution, right? A simulated chi-square statistic, assuming that the additional information didn't have an effect on the response to the question. In each trial of the simulation, the value of the chi-square statistic was calculated. These simulated chi-square statistics are displayed in the dot plot below. So again, it was a simulation, so they're making no assumptions. They're not running this trial more than once. It's a simulation. So based on the results of that dot plot, what conclusion could you make about the original hypothesis that we wrote in A? You know, the null is that there is no difference, and that the alternate is that there is some sort of difference. Well, if you notice all those chi's, because 24 of the 100, and I think you could count all those dots if you really wanted to, but 24 of the 100 resulted in a chi-squared value of 6.12 or greater, the p-value of approximately 0.12 or 0.24 can be assumed. Because the approximate p-value of 0.24 is greater than alpha, we would have to reject the null. We would not have convincing evidence that the true distribution of responses is different from the two questions. And if I said reject instead of fail to reject, I'm sorry if I misspoke. I meant to say fail to reject. This, again, this chapter is not covered on the modified AP exam. I just wanted to go over it as a reset recap. Some of the topics are older topics, so it's important to discuss. Your assignment comes up, but here is a con practice. For the assignment, you can literally go to anything on the chi-square and practice if you'd like to. Or you can practice older things and submit, and I would understand that that's what you're working on. You're working on stuff for the AP exam. Just let me know. So here are those assignments. Ta-da! See you in the next video.